Spheres, finding the volume of a sphere. On the first slide, we have the equation for the volume of a sphere. The volume is equal to 4/3 pi r cubed. Example 1. The drama club makes a big ball from foam to hang above the stage for a play. They plan to cover the surface of the ball with metallic fabric. What is the minimum number of square meters of fabric that the club needs? So before we can find the surface area of the outside of the sphere, we need to find the radius. And since we're given the volume in the question, we need to start there. So I'm going to first write my equation. Volume is equal to 4/3 pi r cubed. We'll plug in what we know. So we know that the volume is 1.8 meters cubed, or cubic meters. And now we have to solve for r. So I will remove that 4/3 first by multiplying both sides by 3/4. So the numerator cancels with that denominator, and the numerator of 3 cancels with the denominator of 3. So we simplify the left-hand side, and we get 1.35 is equal to pi r cubed. We'll divide both sides by pi to eliminate the pi on the right-hand side, and we're left with r cubed is equal to 1.35 divided by pi. So the next thing we have to do is get rid of the cube on the right-hand side. So that means we have to take the cubed root of both sides. So you may have to look on your calculator to find the cubed root. Depending on your calculator, sometimes there is a button that has that cubed root, and then you just put the number underneath in. Sometimes it'll have this little box with that cubed root, so you have to tell the calculator that you want this to be a 3, and then you have to put the number inside. So you might have to Google and find out, based on your calculator, how to find the cubed root. You need to know. Once you take the cubed root of each side, you get r is equal to 0.75. So it's really important that you actually put this into your calculator, because I want to make sure that you know how to use your calculator. So don't just take my answer at face value, actually plug it in and make sure that you're getting the same answer. So now that we have the radius, we need to find that surface area so we can identify how much fabric we need. So surface area of a sphere, this may be a new formula, is 4 pi r squared. So make sure you write that down too. So we'll plug in our radius of 0.75, which is what we just found. And we simplify this and we get approximately equal to 7.1 meters squared. So our units are meters squared because now we're talking about surface area of that fabric. So we need 7.1 meters squared of fabric in order to cover the sphere. In example 2, we're asked to find the volume of a hemisphere. So a hemisphere is just half of a sphere. So if we start with our formula for a sphere, 4/3 pi r cubed, and we take half of that, so I'm just going to multiply that by a half, we can actually simplify this equation. So the denominator of 2 goes into 4 2 times. So the volume of a hemisphere is actually the equation of 2/3 pi r cubed. So you can memorize that, or you can just find the volume of a sphere and cut it in half. Whatever makes sense to you. So let's plug in what we know. So we have 2/3 pi, and our radius is given in our diagram as 4. We plug all of this into our calculator and we get 134.04. And it doesn't look like we have any units. Again, put this in your calculator, make sure that you're getting the same answers. There's nothing worse than knowing how to do problems on assessments, but then doing your calculations wrong. Example 3. A solid is composed of a right cylinder and a hemisphere as shown. If the density of the solid is 100 kilograms per meter cubed, what is the mass of the solid? So just so you know, density and mass are used interchangeably. So let's start with finding our volume. So we will find the volume of the cylinder first. Volume of a cylinder is pi r squared times the height. So the radius of our cylinder is half the diameter. Since our diameter is 2, our radius is 1. So we get pi times 1 squared times 3. So this is going to simplify to be 3 pi. Then we will find the volume of our hemisphere. So the volume is 2/3 pi r cubed. Remember, I'm taking the volume of the sphere, which is 4/3 pi r cubed, and dividing that by 2. So that's where that 2/3 come in. So 2/3 pi. The radius is the same as the radius for the cylinder, so it's going to be 1. 2/3 pi. Now we need to find that total volume. So we'll add together the 3 pi plus that 2/3 pi. I'm going to put that into my calculator to get a decimal, and that gives me 11.5 meters cubed. Now the question is asking for the mass. Right now we just have that volume, but we're given a conversion. The conversion is 100 kilograms over 1 meter cubed. Now in the last video, I talked about how to cancel your units when you're converting. We have 11.5 meters cubed, so I'm just going to transport this up here. 11.5 meters cubed. So it looks like I'm in a good spot here because I have meters cubed in the numerator, and I also have meters cubed in the denominator. By doing that, I can cancel them. So what I'm left with is 11.5 multiplied by 100, and that's going to give me 1,150, and my units now are kilograms. This last slide is just if you're curious about relationships between some of the different volumes that we have talked about in this chapter. You don't need to understand this breakdown entirely, but I just thought it may be interesting for you to kind of tie everything together.